Hello friends, I welcome you all to this class. This is mathematics class. Today we'll be considering this topic we introduced in our previous classes. We'll be considering more examples on this topic. So, in our previous class, we defined the domain of a function. Assuming that f is a real valued function of real variable, then the domain of f, which is noted as dom f, is the set of all x elements of real numbers such that f of x is a real number. That is the set of all real numbers such that if you put them inside the function, you get a real number. So this gives us the definition for domain of a real valued function of real variable. So we'll look at this third example we want to consider. They ask us to find the domain of third root of x minus 4 divided by x minus 2. So this is what they ask us to find. So we start with the solution. So what is given to us is this function, right? Now, if you have root of odd, that is, if you have odd roots, third root, fifth root, seventh root, so all these ones are odd roots. So we have odd roots of negative numbers. We have third roots of -8, third roots of any negative number exists. So it's a real number. But we don't have even roots of negative number. We don't have square root of negative number as a real number. We don't have a fourth root of negative number as a real number. But remember, we are considering real value function of real variables. So the values of this function must be a real number. So for that x to be part, for that value, for that x you put in the function to be part of the domain. So for this case, we have third root, which is what? Odd root, right? So we have third root of negative number. Because of that, we are not going to consider the third root in terms of the what will be the domain of the function. We only consider what is inside, because what is inside this third root is a rational function, which is a function expressed in fraction form. And in our previous classes, I told you that if you have a function which is expressed in fraction form, look at what is here. The numerator here is x minus 4, the denominator is x minus 2, so it's expressed in fraction form. We call such function rational function. So we normally, the domain of this function, to find the domain, you have to remove those points that will make the denominator to be 0. You remove them from the real line. So, and other points will now be your domain of the function. Because if you have a fraction, you will not allow the denominator to be 0, because if the denominator becomes 0, you get infinity, and infinity is not a real number. So try to remove the points that will make the denominator to be 0, right? So we can call this function, we can call it f of x. Let f of x be equal to third root of x minus 4 divided by x minus 2. So then we are looking for what? The domain, right? Then the domain of f, which is dom f, will be, let's draft the sketch for the domain. This fraction, that's x minus 4 over x minus 2. The fraction, we don't want infinity here, right? That's the only one that the third root does not exist. But third root of negative number, positive number, 0 exists. So we don't want this quantity to be infinity. And the only time it will be infinity is when the denominator is 0. So let's remove that point that will make the denominator to be 0. So what is the denominator? X minus 2. So if you set it to be equal to 0, if you solve, you will now have, if you move negative 2 to this side, you have that x equals what? Positive 2. If you move negative 2 to the right. So what will make the denominator to be 0 is what? When x is 2. Because if you put 2 here, you have 2 minus 2, which is what? 0. So I'm going to remove 2 from the entire real line, and it is only 2 that will make this denominator to be 0. So we remove it. Here is, so we assume that for this is your real line, this is negative infinity, this is positive infinity, and the center point is 0. So we assume here is 1, and let me say here is 2, right? So we are removing 2. That is the only 2 we are removing. So come here and remove 2. We remove 2, right? If you remove 2, then you are going to have numbers from here to here, right? So we say we consider negative infinity comma what? Negative infinity comma 2, right? Then union, we now do this side from 2 to what? Positive infinity, but 2 is the one we are removing. So use open bracket for 2 because 2 is not inclusive. If the point is inclusive, use what? Close bracket, because we are removing 2. So you have 2 from 2 upwards is also inclusive. It's only 2 we are removing. Then infinity, towards infinity, you write your infinity, and you use open bracket for infinity because infinity is not a real number. So we are considering numbers between negative infinity to 2 and from 2 to positive infinity. 2 is not among, right? So it's only 2 we remove that will make this denominator to be 0. Other points will give you real numbers if you put them here. So that will be the domain of this function. Thank you so much for being part of this class. We expect you in our upcoming class. Bye.